Hi students, today we're going to go through your geology on Mars slides with new evidence about rocks. So we're going to start off reviewing the triangle landforms that were captured by NASA. We're going to complete slides 31 through 36 today and kind of finish out our geology on Mars notebook. I have an ed puzzle I'd like you to watch, and just a reminder, there is a quiz Thursday, Friday for you to prep for and hopefully get A's on when you're done with it. So to start with, you're going to open up your Geology on Mars notebook here, and we're going to review slide 30. So we were looking at information about a triangle landform that was captured from an image on NASA. So when I'm looking at the image from NASA, we see that this picture was shot by a spacecraft orbiting the planet, and it's showing the elevation of the channel. We found that the channel is going downhill, and at the base is a triangle-shaped landform. And these triangle-shaped landforms are found on Earth as well. And in fact, you were supposed to research those landforms yesterday, and we see that the landforms that were created by water had a wider base to them. There we go. Here's the side. So they have a wider base to their triangle. And then more importantly, the rocks that are found at the base of this channel are made of sediment. When we look at the triangle-shaped landform that's created from lava, it has a shorter base to it. And more importantly, the rocks that are found here are black lava rocks. So really, if we can determine what type of rocks are found at the base of our channel on Mars, we can figure out which geologic process formed the channel on Mars. So we're now going to go to slide 32 in our notebook. Oops, here we go. And so we've got new information about the channel on Mars that has mostly come from the satellite image and scientific models. However, rovers and landers developed by NASA have made it possible to collect information directly from the surface of Mars. So when we think about the channel on Mars and what information we'd want to collect at the surface, to determine if the channel was formed by flowing lava or flowing water, in our response, we want to say that if we can determine the type of rocks found at the base of the channel, then we can state which geologic process created the channel on Mars. So I'd recommend you pause this video and you type in the response. Okay, now the Curiosity rover has many different kinds of scientific instruments on board, including a camera that takes high-quality images of Mars' surface. Since NASA scientists were interested in the channel on Mars, they sent Curiosity to explore the surface near the channel. We will look at the image of the rock found near the base of the channel. Now here's the fun thing about the Curiosity rover. In your Google Classroom, I have given you a link that sends you to the homepage of the Curiosity rover on NASA. This rover is still on Mars today, and it is still working. It has been in mission since 2012. And it has worked 3,020 sol days on Mars. So that's 3,020 Martian days, which is just a little bit longer than an Earth day, like 40 minutes. It's also still collecting research. If I click on mission update here, this was actually published yesterday, February 1st, 2021. And it talks about creating here it is, triboelectric effect on the planet, which is essentially static cling. So think about, I like how they describe it. When you get clean clothes out of the dryer and it shocks you, that's what they're hoping to create on Mars. So kind of cool that this rover that we're looking at in our notebook is actually still working today. So we're going to review some new information on NASA along with the background information of rocks. And then the Universal Space Agency has sent us rock samples on Earth to help us better understand how the rock types are related. So on slide 34, there is a link to a rock information slide that you're going to click on, and it's going to give you information about the rocks we're going to look at closely. We're really going to start with number 2, slide 2 here, and it's stating that the rocks found near channels on Mars are created because flowing water picks up the sediment, and as the sediment is carried by the water, it becomes more rounded and shaped. The rounded sediment is deposited in a new location. Over time, the sediment becomes pressed and cemented together to form a solid rock called a conglomerate rock. Okay, we're actually going to have you type in conglomerate rock on slide 35. All right, oops, right here, about information on the channel of Mars. So here we want to state that where it says do this box first, conglomerate, you want to state that when sediment is carried by water, it's deposited in a new location. Over time, they are pressed and cemented together, forming a conglomerate rock. And then I have an image of the rock on slide 3 right here. So you can see it's made of tiny little pieces of rock. Going back to slide 2, we have rock found on Earth near channels formed by lava is shockingly made by lava. So hot liquid lava rock cools and forms into the solid rock known as lava rock, but the scientific name is basalt. All right. So on slide 3, we've got the image of the basalt rock here, these nice black rocks that are porous, and they're the same material all the way through. So on slide 35 of your notebook, where it says do this box second, the basalt rock, you want to state that when lava cools, it forms black hard rocks called basalt rocks. Then lastly, we're going to do our rock on Mars. Okay, so we've sent the Curiosity rover to the base of the triangle-shaped landform on the channel, and a camera on the Curiosity rover took this image near the bottom of the triangle-shaped landform at the base of the channel on Mars. The instrument on Curiosity determined that the rock was made of pebbles and other sediment cemented together to form this solid rock. So if you notice, this is made from pebbles and sediment that are cemented together to form a solid rock, which means that we now know our channel is made of water. So we want to add an X here to the claim that flowing water formed the channel on Mars. Then you're going to fill out the last bit of information here explaining how this key evidence, the image of the rock on Mars, really solidifies our knowledge that flowing water created the channel. The last thing you're going to do today is you're going to go through the evidence cards again, but now that we know which geologic process made the channel on Mars, you're just going to copy and paste the cards that involve water into your slides. And then you're going to arrange them from the strongest evidence to the weakest evidence. So card F should be at the top of your slide and card A should be at the bottom. I hope you have a great day. And if you have any questions, please feel free to reach out and let me know.